In this video, I'm going to show you how to program 6 compound interest formulas into the TI-84. Here's the beginning compound interest formula, where A represents the future value, also called the amount. P is the present value, or principal. R is the interest rate. T is the time in years, and M is the method of compounding. So let's put this into our calculator. So to put this formula into our program, we're going to start with the program button right in the top middle of the screen, then new, enter. We'll name this program COMP, which stands for compound interest. And then we'll put the letter that we're solving for, which in this case will be the A. So our program name will be COMPA. Now, the variables which we need to make provisions for are the PR, M, and T. So we start with program IO and then number 2 for prompt. We type the 4 letters separated by commas. The P is alpha, and then P, comma, right up above the 7, and then R, comma, M, comma, and T. Press enter, and then we enter our formula in calculator format, which we would have a P times, parentheses would be fine, 1 plus R divided by M close parentheses, exponent, parentheses again, TM, enter, and then display the answer. That's program IO number 3, ANS, which is second, and then the bottom key, and that's our program for the compound interest where we're trying to solve for the future value. So let's see how the program works. In this problem, we're given the P, R, T as to find the A. Now we're also sort of given the M. If you notice, it's kind of disguised here. Quarterly means that M is a 4. So we take out our calculator and run our COMPA program that we just entered, and then as each letter comes up, we type the value of that variable. Using our beginning compound interest formula, we're now going to solve for the P in this formula. This is required if we're going to use our calculator for the formula. So we'll start by dividing both sides by the stuff next to the P. That means all of the stuff next to the P. And we actually could use that on our calculator. If you recall, however, when you've got something on the bottom with an exponent, you can move it out of the bottom if you change the exponent to a negative. So we're going to write it like this. So here is what the program would look like for that formula. You can enter that into your calculator. If you need help, you can go back and review the earlier one to see how to type that. As with the previous formula, all we have to do to solve a problem with the formula is to enter the values as the letters come up. Now, the trickiest one of the bunch is the time. So let's go solve for the t. To begin with, if we divide both sides by p, we get something here that's in exponential form. Here we have 1, 2, 3, base, exponent, other number. Change that into logarithm form. The base is the 1 plus r over m. The logarithm is the exponent, and then the other number. Now we're almost there. We're trying to solve for the t. We just need to divide both sides by m. So that's what our formula looks like. Unfortunately, we're going to have to change this so that we can put it into our calculator. The log with a different base, we have to split into two ln's. And the program for that would look like this. Let's try that out with this problem. Now, remember, monthly means we're going to be using a 12 for the m. And we'll repeat what we just did with the continuous compound interest formula. So the first one of these formulas is the one where we are solving for the a, which we already have our formula for a. We will just need to call that something. Now, I've used a naming scheme, much like what I started with. We want to call this program CONT for continuous compound interest, followed by the letter A, which indicates we're solving for the variable A in that formula. And it works the same as the previous programs. When you run the program, you should see each variable and then a question mark where you type your answer. And of course, this time you won't have an M because it's continuous. Very similar to what we did earlier. To solve for the P in this formula, we just need to divide both sides by whatever's next to the P. And we could actually put that into our calculator. But like with the previous one, I'm going to take the e to the RT, move it out of the bottom so that we don't have to type fractions, and then program that formula as CONTP. And here's an example of how that works. You can again try these out if you are doing the programs on your calculator. And our last formula is solving for the t in the compound interest formula. So we need to divide both sides by p. Now we have exponential form, the base, exponent, and other number. We can change that to logarithm form. And to get the t by itself, divide by the r. So we can program that into our calculator. And I've called that CONT for continuous compound interest, followed by the letter we're solving for, which is the T. And here's our example using that program.